Okay, this is Advanced Math Unit 10 Morning Review. Make sure you put your name on it right here. There's no spot for it, but please make sure you do it because we will be turning this in. Find the asymptotes. Va, ha, and sa. I didn't ask for the domain or intercepts, just the va, ha, sa. Remember, we find va, ha, sa after we reduce. Is there anything to reduce here? No, but what do you notice? There's no variable in the denominator. So what does that mean for all of these? None, none, and none. Got it? Okay. Bless you. B, va, ha, sa. X plus 3 over x squared plus 4. I try to factor and reduce first for the asymptotes. Is there anything to factor and reduce? Yes or no? Okay, how do I find vertical? Where do I look? I heard somebody whisper it. Where do I look? What makes the bottom 0? X squared plus 4 equals 0. Can I factor x squared plus 4? Is that difference of two squares? It is not. X squared equals negative 4. When we're dealing with asymptotes, can we take the square root of a negative? So we don't put undefined. We don't put D and E. What does that mean for the vertical asymptote? There are none. All right, horizontal. We take the limit as x approaches infinity, which means we look to see if it's top heavy, bottom heavy, or the same. Which one is it? Which means what? Y equals 0. Slant only happens if it's top heavy. Is this top heavy? So that means none. So there's only a horizontal of y equals 0. Yes? D and E is used to, what is the limit as x approaches infinity? You do the work, D and E, it does not exist. When you're listing the asymptotes, it's like finding the x-intercepts. If there aren't any, you put none. Got it? Okay, f of x equals this one here. Let's do our va, ha, and sa. This one is tricky, and I hope everybody is listening, because if you're not careful, it's going to get you on the test. What did I say earlier? You do what first? Factor and reduce? Yes? Okay, so can you guys double bubble the top? Okay, anybody factor it yet? Plus 5 plus 2. And what can I do next? Leaving behind x plus 2 and 3x plus 6. Now, are we ready to find the va, ha, and sa? Okay, I think I heard maybe 2 people say it. And if the rest of you didn't catch it, you're going to mess it up on the test, so please listen. This is a little tricky. It looks right here like they gave it to you in factored form, but was it truly factored all the way? No. What can we still factor? Right here. And does it make a difference? Let's check. I have x plus 2 at the top. I take out the 3, leaving behind x plus what? And then that reduces, leaving behind what? 1/3. Even if it was x plus 3 over 3 or whatever, there's no variable in the bottom, so what are all of these? None. So what I'm getting at is be careful. It's kind of a little tricky here. It looks like it's in factored form, but it's truly not factored completely. Does that make sense? All right. True or false? The graph of y is the same as y equals 24x squared over 2. And then let's look at the next one before we answer part A. The graph of y equals 2x plus 7 is the same as y equals 2x squared plus 7x over 7. Okay, On the first one, do you agree I can reduce the 24 and the 2? And what is 24 divided by 2? 12x squared. So is that true? Yes. On the next one, can I reduce an x or factor out an x and then reduce? So is this one true? This one is not. Does anybody know why? Raise their hand and explain to the class why this one reducing is true, why this one reducing is false.
Because
Hold on, I called on him. It's okay. Yes.
When you find the domain, you have to look to see what x is, and I right there x equals 0.
And so what does that mean about the graph? What is this graph going to have that this one's not?
So in the x graph, x is not equal to 0.
Good.
But when you reduce it, like that, it's basically.
Okay, so you're saying x cannot equal 0, but when I reduce it, I end up with the same graph, but it has something slightly different. Yes?
Isn't it like you can't divide by x because you'll be missing one extra answer at the end for solution?
Okay, so we can't reduce by x when we're looking for the domain, but would I reduce for x when I go to graph it? Yes. What does that mean about the graph? There's a hole in the graph. Does that make sense? Yes or no? Yes? So they were all correct. It's not the same. He said because when you reduce it, before you reduce it, x cannot equal 0. And then he said, and after you graph it, which one's going to have the hole, the first one or the second one? This one here. Do you agree they're both going to be the same line? 2x plus 7 is going to look something like that. Only this one's going to have, this one here is going to have a hole at the 0. Does that make sense? Where this one will not. This will be just a straight line. Okay, graph. Any questions before we get to graphing? All right. D, va, ha, sa, x-intercept, or intercepts, and y-intercept. Okay. Domain we do before we reduce. There's two things, so all reals such that x cannot equal what two things? -3 and +3. Do you guys all agree with that? Now I'm going to factor to see if anything reduces, and even if it doesn't, I'm still going to need it to factor in order to find my zeros. What comes out of the numerator? What GCF? Can I take out a negative x squared? Leaving behind what? Positive x minus 5. Do you guys all agree with that? Over x plus 3 squared x minus 3. Questions so far? All right, did anything reduce? Will anything reduce? Okay, vertical denominator, what two things will x equal? And you have to write them separately. X equals -3, and bless you, and this one?
3.
Now let's look at the multiplicity. What's the multiplicity from the -3? We got that here. Multiplicity is 2. What about from the x equals 3, which we got here? 1.
Because when I'm called, we have to call the SRC. So I have to do attendance and go home and change and come back. But when I call the SRC after this. Okay. Yeah, sorry.
It's okay. Okay, horizontal. Are they going to call you out, Melody, from here? Is the office going to call you out, or are you supposed to go straight up there?
Well, this actually just goes straight up into the attendance. That's been my
Okay. Okay. This is being recorded, so you can watch this later online. Okay. Don't forget, test tomorrow, guys. Horizontal. All right. They're yes.
Studying her mom and making her miss because she's at dress code and miss their education. Yep. Yeah. That's funny.
It's not funny because it's on you guys. You know what the dress code is, so it's not.
Then how is that more distracting when we have...
All right. Shh, guys. Okay, horizontal. We take the limit as x approaches infinity. Is this top heavy, bottom heavy, or the same? What's the degree at the top? Do not add. 3. What's the degree at the bottom? You do add. So it's the same. Do you guys agree? Yes or no? Y equals, leading coefficient at the top is the -1 or the 5? -1. At the bottom, there's a 1 and a 1, so it's just y equals 1. Do you agree? Thank you.
Now, what happens if you have, what if you have two different coefficients at the bottom? Do you multiply?
So if there was like a 2x there and a 3x there, you would multiply them. All right. So y equals -1. Slant, what do I put for slant if it's not top heavy? None. X-intercepts, when we set this equal to 0, what's going to happen to the bottom? It's going to cancel out, so I have 2 zeros. What are they? 0 and 5. X equals 0 and 5. Okay. Which one bounces, or do they both cross? 0 bounces, and the 5 is a cross. Y-intercepts, I plug in 0 for everything. So that's going to give me 0 plus 0 is 0 over 9 times -3. So 0 over -27 is still what? 0. Okay. Questions before we continue? I believe this is one similar to what you guys had on the quiz. You didn't put one on his desk?
You didn't pass it enough.
I thought I gave you an extra. I apologize. Okay. Guys, so I believe I was saying this is one similar to what you had on the quiz, and this is one kids typically miss on the test. So I want to make sure that everybody is paying attention. Vertical, x equals -3, 1, 2, -3. And it is even. What does even mean as far as the vertical asymptotes go? Same direction. Okay, the other one is +3. And that multiplicity was 1, so we're going to call that odd, which means opposite direction. And horizontal is y equals -1. Okay, do we have to do a test value when the horizontal is -1? No, only when it's y equals 0. Okay, x-intercepts 0, which is a bounce, and then +5. 1, 2, 3, 4, and 5. Okay. Now I often have kids that will look here as a guide and then figure out where it goes. You don't do that. You start at the far left. Don't look at any intercepts other than what's on the far left. Are there any intercepts at the far left? No. So will I be at the top half or the bottom half? Why can't I be at the top? There's no x-intercepts on this side. So I'm at the bottom. Does everybody see that?
And then now, if it was on the, like, it was y equals 0, we'd have to do the
Test value.
And how is the test value? Is one outside of it?
So you would pick like -4 or -5, anything to the left of it.
And then if it's negative, it's in the bottom. If it's positive, it's in the top.
Yes. Okay, even means the same direction. So am I coming from the top or the bottom? And in order to hit that intercept, will I have to cross that horizontal? Yes. Is it okay to? So yes, it's not okay to cross, but you only cross. Okay, you only cross when necessary. Is this a necessary situation? Yes. So I'm coming. I cross it now. If this were even, I would cross it and come up like a tangent type graph or a cubic type graph. But since it's even, where is it at? It's a bounce, so I bounce and I come back down and I cross the asymptote again. Do you guys remember this one from the quiz? Yep. Okay, odd is opposite direction, so I'm going to be coming from the top, which makes sense because I have that intercept up here to hit. And I approach the asymptotes like so.
So why does it go down, back down again?
Because this 0 right here was a bounce. It came from the x squared. And that's a...
Even has to start from the bottom.
Okay, because this is even, it has to start from the bottom.
Okay.
And that even is coming from this. Because this is even, it's a bounce.
Okay.
All right? Okay, questions on the graph? Okay, let's flip over to the back side, please. Okay. D, va, ha, sa, x-intercept, y-intercept. Okay. What is the domain? All reals such that x cannot equal 3. Now let's factor and see if anything reduces. If not, we have to factor anyway to find our zeros. Anybody tell me what it factors to? Minus 3 plus 2. Oh. And does it reduce? What does that leave behind? Y equals x plus 2. What does that mean about Vaha and Sa? Okay. You have two choices. You can graph this. We know how to graph y equals x plus 2.
Notice there's no x-intercept or y-intercept.
Or we can find our x-intercepts and y-intercepts. So I'm going to do that since that's what we've always done. What's my x-intercept? If I set this equal to 0, what's my x-intercept? What is it? Negative 2. Y-intercept, I plug in 0 for x. What do I get? 2. Okay, so let's graph.
And y-intercept is
Y-intercept is positive 2, which makes sense because y equals mx plus b. B is the y-intercept. Do you see that?
Yeah.
Yeah. Okay, x-intercept is negative 2, y-intercept is positive 2, and we make a line, and this is not an asymptote, so this is the actual graph. Good job. There is a hole. So I'm going to go back and fix the hole. Before I do the hole, do you guys agree that y equals mx plus b, that would be a y-intercept of 2 and then up 1 over 1? Yes or no? Yes? Okay. Did you not get one on your desk? Oh, you guys are supposed to put one on her desk. You guys gave them back to me. Okay. So taking a look, was pointed out that there is a hole. Why is there a hole on this graph? Because we did what? Reduced a variable. The domain is all reals except 3, and I don't have any asymptotes to take care of that, so I go over to x equals 3, up to my graph, and what do? I put in open circle. And there's the graph. So this is back. Why is it at 3? Because that was the restriction. X cannot equal 3. Or you can think of it as that's what you reduced. You reduced x minus 3, so you have a hole at x equals 3.
Whatever the restriction is, or and because it's a linear equation, there's no Vaha or Sa.
Correct. All right, because there's no variable in the denominator. All right. Questions? Shh, guys. All right, listening. If they asked you to work backwards from this, could you do it? Okay. Listening. If they asked you to work backwards, which they might, could you do it? If you have this, you'll be given to you a nice graph paper where you can actually find the y-intercept and count the slope. So let's say, what's the y-intercept? 2. And let's say it's really nice and we can count the slope is 1. So do you agree that'll be y equals 1x plus 2? Yes or no? Okay, so that's starting to work backwards. Now, why can't I leave it like this? Because there is a hole. And where is that whole at? It's at 3, so what do I put in both of these parentheses? X minus 3. And that's your equation. Is this the same as what we started with? So if you were working backwards and it was multiple choice, and you write this, could you FOIL that and know it's the same as that? Yes or no? Okay, does everyone understand how to work forwards and graph versus how to work backwards and end up with the equation? Is that a yes from everyone? Okay, last section, limits. Okay, first one is infinity. So if it's infinity, I can use the shortcut. Is this top heavy, bottom heavy, or the same? Same. What's the leading coefficient at the top? 7. What's the leading coefficient at the bottom? 1 or 4? So it's out of order. You guys can see that, yes? Okay, without any work, what's your answer? 7 over 4. No work needed. Do you guys agree? Yes. What was that? Are we going to see our quiz?
If there's multiple coefficients, you can multiply them together. Just take the biggest one.
Okay.
Like say there's multiple on top.
Yes, I see what you're saying. When it's in expanded form or standard form, these are both standard forms. When it's in standard form, you take the leading coefficient, which is 7 and 4, because the bottom one's not in standard form. It's written backwards. But if it was like this, which I think is the one you're talking about on the quiz, something like this, I'm just making up numbers. Then you would do 1 times 1 times 1 over 2 times 3 is 6, so it would be 1 over 6. Because this is factored form, where this is standard form. Do you guys see the difference? Okay, this is the one you guys were all screaming about, like throwing out answers yesterday when I asked, yeah? All right, next one. Guys, a mistake kids make here is they say, oh, it's top heavy, so blah, 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 blah. Is this one where I look at top heavy, bottom heavy are the same? No, because I'm not approaching what? Infinity. That shortcut only works for infinity. This is where I plug it in, but what happens when I plug it in? So, does that mean it does not exist? No, that means I have to do what? I have to factor and reduce. Does that make sense? You have to factor and reduce.
So anytime you're given anything other than infinity, you have to factor and reduce?
Sometimes you can just plug it in. If you plug it in and you do not get 0 in your denominator, you're good. For example, let's say this one over here was limit as x approaches 2. Just plug in 2, work it out, you're done. But when you plug it in and you get 0 in the denominator, you either factor and reduce or use the conjugate. Yes?
If like the top is unable to factor, would that mean it doesn't exist?
Say it again, if what?
If the like top part couldn't be factored.
Or if it does, okay, very good question. I'm glad you asked that one. Let me finish this one off, and I did want to go over that one. Okay, let's finish this one off. It reduces, leaving behind x minus 3. Now what do I do? Plug in 0. What's 0 minus 3? But if you plugged in 0 everywhere, you'd end up with 0 over 0, which is undefined. Right here you could have, after it reduced, you could plug it in. Okay. All right, are we ready for the question that Jason asked? I'm going to put this aside really fast. What if you had something like this? Okay. What happens, guys, and this is on the test, so it's you thank him when you see this one and you know how to do it. What happens when you plug in 2 here? What's 2 minus 2? 0. And 5 over 0 is undefined. Do you agree? Okay, so then, okay, Mrs. Torres said to factor. Is there any way to factor that and reduce it? No. Conjugate's not going to help us on this one. You can try doing the conjugate, x plus 2, 5, x plus 2 over x squared minus 4, but it's still not going to work. What's going to still happen when you plug in the 2? Is it still going to be 0 at the bottom? Yes. So it's not factorable. Conjugate doesn't help. So this is one where what would be your answer? Undefined, D&E. Does that make sense? Okay. So the question he asks is, what if it doesn't factor or doesn't reduce? So this is that example. It doesn't factor, it doesn't reduce. Conjugate doesn't help you. You can try it. You don't have to because it's not going to work on something like this. You plug in 0, you get undefined, so the limit does not exist. Does that make sense? Jason, does that answer your question? Does it make sense to the rest of you guys? Yes? All right. Next one. This is kind of going off what I just said. What's the square root of 4? And 2 minus 2? So that's undefined. That does not mean D&E on this one, because what can I do on this one that this one it didn't help? Conjugate. And you could tell it's going to help because there's a radical. So square root of x plus 2, square root of x plus 2. Does everybody see that? All right. Where's the conjugate piece? The numerator or denominator? What piece did I take the conjugate of? The numerator or denominator? Okay, so that's the piece I'm going to double distribute. The top, bless you, I'm going to leave in factored form. Bless you. I'm going to leave in factored form because I'm going to try to reduce at the end. So whatever's the non-conjugate piece for us, that's the numerator, I'm not going to double distribute. What happens when we double distribute conjugates? Do you guys remember? The middle terms cancel out. So we just do root x times root x and negative 2 times positive 2. What's root x times root x? What's negative 2 times 2? Is it going to reduce? If you don't like the way I just did that double distribution, you can do the whole first, outer, inner, last. The middle terms will cancel out. Leaving behind square root of x plus 2. What do I do now? Plug it in. Square root of 4 plus 2 gives me what? 4. And these are all on the test, and kids miss these quite often. Like they'll say, oh, D&E, because they forgot to do the conjugate. Up here they'll do the same thing, D&E, because they forgot to do the conjugate. Or here they'll say 7 over 1 instead of 7 over 4. Be careful. Questions on how we got 4. All right, next one. Limit as x approaches infinity. Can I use the shortcut on this one? And I heard Janelle say it's bottom heavy. What is it when it's bottom heavy? It's just 0. On all of these are all y equals 0. I haven't been putting y. You don't have to. You do have to when you're listing your asymptotes. All right, are we good? Next one. Can I use the shortcut on this one? No, because that's not infinity. And what happens when I plug in 2? What's 2 minus 2? 0. Does that automatically mean D&E? We have to do the conjugate. Can you guys at this point recognize when it's a conjugate problem? Yes? Okay, and would you recognize that this one that I showed earlier is not a conjugate problem? Do you see that? I mean, technically you can try it, and does it work? It doesn't. Okay, so let's do conjugate top and bottom. Now with this one, kids struggle a little bit. Like this one was a little easier to see what the conjugate was. Here the 4 stays 4, and the radical 18 minus x stays. What sign changes? That minus right there changes to a plus. Again, the 4 stays 4, the radical 18 minus x stays, that minus sign becomes a plus. You have one like this on the test. Everybody ready for us to continue? Okay. Which piece is not the conjugate piece, the numerator or denominator? Okay, so that's the piece I'm not going to double distribute. I'm going to leave it in factored form because I'm going to hope to do what at the end? To reduce. Yes.
Why did we choose to do x minus 2 to the top, or x plus 2 to the top?
Like you did with the other.
It's the same as this one, when there's like that one there, whenever it's just like x minus 2 or x plus 5 with no radicals, the conjugate's not going to help.
So there needs to be.
So the one with the radical.
The one with the radical is the one you choose. That's up here. We didn't choose the x minus 4's conjugate. We chose the root x minus 2's conjugate.
Oh, I thought you just had to do the denominator.
No, it's not.
If you have a radical, you're gonna use the conjugate.
Every time you have a radical, you're going to use the conjugate for this test, yes. And is it always the numerator or always the denominator? No, so it just depends on the problem. All right, can we do double distribution at the top and use our shortcut because the middle terms will cancel out? Yes? What's 4 times 4? And here, I know it's going to be negative because a negative and a positive. What's going to happen when I multiply root 18 minus x times root 18 minus x? Is the radical going to undo each other and just be 18 minus x?
Yeah.
Now, I messed up somewhere and I will fix it. Before I do, does everyone see why this is 18 minus x?
Yeah.
And why this is 16 and why that's a minus? Where did I mess up?
No, what is that?
Distribute the negative. Good. Distribute the negative. If you do not, it's going to end up incorrect. Bianca, ask me your question. Why was what?
I don't understand. Like, why is it not?
Why is it what? Okay. No middle terms. I will show you quickly. I'm not going to show it on this one. I'm going to show it on this one up here. When you multiply conjugates, root x times root x is x. Root x times 2 is 2 root x. Negative 2 times root x is negative 2 root x. And negative 2 times 2 is negative 4. The middle terms will always cancel out whenever there's a conjugate. So it's just root x times root x and negative 2 times 2. That was a shortcut that they've been using, I think, since last year. And we used a little bit first semester. And you weren't here first semester. Okay, you guys got it? So 4 times 4 is, where are we at? 16, and then the radicals undo each other, and I do have to distribute. 16 minus 18 plus x, x minus 2, 4 plus 18, square root of 18 minus x. Has anybody cleaned up the top yet? What does that become? Okay, x minus 2. She started to say negative 2 plus x. Is that the same as x minus 2? Yes, and can I reduce that with the x minus 2 at the bottom? Is that what we were hoping to do? Which is why we left it in factored form. All right, what's the last thing to do? Anyone? Do I do conjugate again? I do not. What's the last thing to do? Plug it in. Now, of all the ones we've done so far, would you agree this one's the one with the most work? All the other ones, and you will have some this easy, the ones we did up at the top. Okay, 1 over 4 plus the square root of 18 minus, what are we plugging in?
2.
1 over 4 plus the square root of what?
16.
So 1 over 4 plus 4, which is 1/8. Questions? No questions?